welcome the COO and co-founder of Plus, Dr. Shawn Kerrigan.
Great, thank you. It's great to be here today. Let's see. How do we get the? We got it? Oh, good. Okay, great. So I'm going to talk about deploying autonomous driving technology via software-defined vehicles at scale. So first, a little background on Plus. So our mission is to make transportation safer, easier, and more sustainable. We got started back in 2016, and we've been focused on developing autonomous technology, sort of level 4 autonomous technology for trucks since very early on. We now have global operations. We've expanded from our headquarters in Silicon Valley to now we have offices here in Europe, in Munich, as well as in China, and we're now over 300 people and growing. Throughout that time, since 2016, we've done a lot of different demos as we've developed out that core level 4 technology stack. Some of the more significant of those was our first driverless demo back in 2018 in a port setting. And then last year, we did a driverless demo on a highway, and so I'll show you a view of that a little bit later. Now, one of the things that makes us different in terms of developing autonomous technology is our view on the need to focus on how do you productize this technology? How do you take it from a demo to the stage where it can be released as a real product? And we think a core foundation of that is having really broad experience so that you know that the technology has seen that long tail of all the things that can happen out there in the real world, and be certain that you can handle that both in simulation and in the real world. And so towards that end, we're focused on how do we get this technology to have experience on the scale of billions of kilometers of experience so that you can safely deploy it in a driverless fashion. Now, it was a bit that view towards productization and the understanding of how this technology could actually help trucks with drivers still in them, which led us to release our first commercial product last year, which we call Plus Drive. And we're now deploying that across US and China. So I'll give a little bit background on why we're focused on this problem, and then tell you more about how we're deploying. So why trucks? So within the trucking sector, there are 3 big challenges that we saw. So one is that there's a big driver shortage. And this is true across all the markets that we operate in. It's true in the US, in China, and here in Europe. So for example, in Germany, every year about 30,000 truck drivers leave the business, and only about 17,000 new drivers come in. And so there's an ever-growing shortage for drivers. Second, there's a trend of increasing accidents in this space. And so there's a need for technology that can help make driving safer. And then third, there are rising operational costs. This is due to fuel costs, labor costs, all sorts of costs. And so these are all problems that can be addressed with autonomous technology. Now, from a business perspective, right, we think that some of the important things that we can address here is that we can increase the utilization and uptime of trucks. So if you have an autonomous truck, you're not limited by the driving hours of the human driver. You can operate basically around the clock. And then if you also, autonomous trucks can drive really efficiently. So you can operate much more fuel efficiently than you can with traditional drivers. And then third, when you deploy this technology into trucks with driver in them, with things like our Plus Drive product, it makes driving much safer and easier. And so it's easier to recruit new drivers into the business, as well as retain drivers longer. So those are some of the core parts of what we see as the value proposition of autonomous technology for trucks. Now, beyond that, there are actually some really important societal benefits that we're really excited about. This goes back to the mission, and it's sort of the mission-driven part of why a lot of the folks on our team are really excited to work on these problems. Now, one is that we can really improve road safety. So there's thousands of people that die every year involving accidents with Class 8 trucks, these large, heavy trucks. And when you look at the underlying causes of those accidents, it oftentimes comes back to fatigue, distraction, or driving too fast for conditions. And those are all things that autonomous technology addresses. This technology doesn't get distracted never gets tired, and it always follows the rules of the road. So there's a huge opportunity to improve road safety. Second, you can reduce the time to move goods across the continent. And this is really significant in the context of a lot of the dynamics in the marketplace today. So there are some markets like, say, agriculture, where if you can cut the time to move goods across the continent in half, you can really improve the shelf life and reduce spoilage. And then there's other industries like e-commerce, whereas there's this growing expectation of customers getting their packages sooner. If you can cut the time down to move goods across the country, you can really help achieve faster delivery. And then third, tied to the fuel savings, by driving more efficiently, you can help reduce carbon emissions associated with trucking. So now I'll show you here a video of the driverless demo that we did last year. And this really showcases what the future will look like as we get to the stage of having driverless trucks operating fully hub to hub. So I think it's really exciting to look towards the future of what transportation can look like. Now, one of the things we realized is, as we produced this type of demonstration project and built out that technology, is that there's still some work to be done before you can take this sort of exciting demonstration and release it as a full product. And the difference is really, in this case, this will work under sort of relatively known and reasonable conditions. And to release a fully driverless product, you need to have the technology robust enough to handle all the long tail of corner cases of things that can happen out there in the real world. And that will take a lot of time and road experience to get there. Now, the other thing we found, though, is that many of the benefits of this technology can actually be achieved if you apply the same technology into trucks with drivers in them today. And that's how we came to our progressive plus drive strategy, right? So today, we're now deploying, as of last year, plus drive trucks, which is taking that same level 4 technology that you just saw a video of, and deploying that into trucks with drivers in them to provide a very high-functioning level 2+ type system. And so this is a system where we've taken that software and we've governed it down just to operate on highways under conditions where we know it's been proven and safe. And so we can provide benefits in terms of improvements in safety, improvements in fuel economy, and improvements in driver comfort with that technology today. And then as we continue to build the experience from that technology, as it continues to do extensive driving worldwide, we can get to a fully autonomous future as we've captured more and more of the scenarios and be confident that it can truly handle everything that the world can throw at it. So with this, we're now offering basically a full suite of sort of driver-in to driverless solutions. And those solutions, because it's based on a virtual driver, they work across really any powertrain. So this works on traditional diesel trucks, on CNG trucks, on electric trucks. It works basically across all drivetrains. It's also agnostic to the vehicle platform. We're running this today on trucks in China and in the US and now in Europe. And with that, we're able actually to start delivering the value to customers starting last year as we started shipping this product. So I'm going to talk a little bit about what some of those features are and how the application of this technology is a bit different. So here we have the long list of specific features, right, in terms of lane centering or adaptive cruise control or driver or sort of system-assisted lane changes. But what these really are is translating effectively the ability to drive safely on highways back to discrete features for the driver. And so these are some of the features that we planned for in terms of naming them, but what was interesting is we started to deploy this as we've continued to get a lot of great feedback from drivers in the field. And so some of the things that we expected drivers to love have worked out great in terms of the ability of the system to handle stop-and-go traffic and sort of tight merges, because those are oftentimes very stressful driving conditions. And now as the system automates that, the driver gets less tired as they're dealing with those situations all day long. Now, there are other things, like the ability to handle windy conditions that we didn't originally anticipate, which is that we started to get the feedback that on windy days, the driver otherwise would have to spend a lot of energy just fighting to keep the truck in lane all day. And now, with our system, it'll just hold the lane, and the driver is freed up really to maintain broader situational awareness of what's going on. So that's an example of those things. Just as drivers experience the ability to drive safely on a highway, they start to recognize certain benefits of having the technology there. And there are even new features that we're now adding as we're able to deploy through over-the-air updates that are based on feedback from drivers and fleets. So for example, one of the new things we're working on is the ability to mitigate bridge strikes. So this is still a problem today where trucks will drive into bridges that are too low for them to fit under. And that can happen because even the road elevation can change because of road construction or other things. And so with our system, we're able to actually precisely measure the bridge height and make sure that the truck and trailer are able to fit under the bridge before they attempt to do so. So as we're developing this technology, we brought in a lot of drivers to go and test the technology and give us feedback on it. And we asked them to go out for a test drive and then come back and give us rating on a scale of 1 to 10 and other feedback they might have. And what we found is that we were getting all 9s and 10s, and we even got an 11. So we filmed this video of what that was like in terms of how drivers reacted to experiencing the system for the first time.
I've driven dump trucks and dumps, moved construction equipment.
I'm like a multi-use person.
My biggest challenge or concern as a driver is other drivers. So I'm not worried about what I'm doing, I'm worried about what the person next to me might do or might not do.
On a commercial vehicle, it takes a lot longer to stop. If I was to have this system in my truck, it would make my job a whole lot smoother, easier, and a lot less stressful.
For me, I think it would be less fatigue because you don't have to worry about gas, brake.
Basically, you go bumper to bumper and you don't have to keep playing with the feet, only with your hands.
I thought it would be more like my car, where it just keeps you in the lane. With this system, it's way more advanced than that. It pretty much just drives itself.
The sensors did very well, anticipating the car coming on from the merge.
I feel totally safe with Plus Drive. If I had a system like Plus Drive, I would consider going back into the long hauls again.
So we sometimes get the question, how is it different that we've taken a level 4 system and applied it down to as an advanced level 2 plus type system? And so this here is showing sort of the difference in architecture, which is that going from sort of a more classic architecture of sensors with small compute attached that then provide object lists for another compute unit to combine, we're instead have a setup that looks much more akin to a level 4 setup where you have sensors, radar, LiDAR, and camera that are streaming back the raw sensor data to a central compute that's able to combine that and really understand the world around it and make driving decisions. And so I wanted to share a few examples of how that really helps advance the state of the art in terms of what can be done in terms of helping drivers operate trucks. So here, this first example here is just if you have the system then operating on the highway, One of the challenges with trucks is they take a while to slow down and to stop. And so you have to see far ahead and plan far ahead for any actions that you're going to take. And that could be a problem for systems if you're operating down a highway and it's about to go around a turn and there are really slow vehicles up ahead. Because with, say, a traditional sort of radar system, the radar will look out ahead and not see anything. And really, to solve this problem, you need to be able to identify vehicles and place them in their lanes hundreds of meters down road. And so the way this works in a system like ours is that with the camera-based system, you can identify the objects hundreds of meters down road. You can also then identify the lane path that far down road. And then by combining that with a map understanding of what the world is like and what the road ahead looks like, we're able to actually place vehicles in their lane hundreds of meters down road. And then the planner is able to decide, do we need to slow down, right? Do we need to start preparing for slower traffic up ahead? Another example is sort of the classic stopped car under overpasses. This is oftentimes a challenge because for a radar-based system, if the car is stopped, there's no way to differentiate between the car and the overpass, right? The radar returns that there's something there, and if you know there's an overpass, right, you can't distinguish because you can't tell the difference in elevation between a car and an overpass. And at the same time, since it's under an overpass, that it's shaded for the camera, so it's harder to distinguish. But with this type of situation, if you have the camera and the LiDAR, you can use the camera to identify what the region of interest is, and you can also use basically the LiDAR point cloud to determine if there's anything on the road ahead of you there that you need to watch out for. And so you're able to actually safely identify and slow down or stop or change lanes if needed. I could go on with lots of examples. I'll just cover two more quick ones here. So another one would be missing lanes, right? So this is something that we as people deal with every day. There are oftentimes lane markings missing on the road. And this can be because they were just worn away, or it could be because of construction. But we understand roughly where the road is and where we should be driving. So for this sort of system, you can do the same sort of thing, right? The camera can determine what is the drivable area, right? The LiDAR can check to make sure that there's no unknown objects there in front of you that you can't handle. And then you can use the map to make sure you really are cross-validating where you expect the lanes to be, such that the system can still continue to drive through areas with poor lane markings or missing lane markings. And then on a related note, there's also lots of situations out there in terms of different debris on the road. And sort of this generic obstacle problem is one of the more challenging problems for camera-based systems to figure out. But here, when you have camera and LiDAR, the LiDAR can identify basically where there are objects on the road. And then you can really focus your attention in terms of the cameras in deciding whether or not those are objects or something you need to do anything about. So I'll skip over this last example here in the interest of time. Just wanted to close with saying that we're super excited to be here, super excited to be growing our office here in Germany and working with partners like Iveco. I'd encourage you all to come over and check out the autonomous truck that we have in Iveco's booth. And we're really excited to basically be now building the team up here and applying the learnings across all the markets we're in to improve this overall system and be able to continually update it and improve the deployed products globally. So thank you very much.
Okay. Thank you very much. Thank you to Plus for your sponsorship. We couldn't do this event without our sponsors, and we do really appreciate it. Guys, we are going to take a very short break. Math is not my strong suit, but I think it's going to be an 11-minute, 12-minute break. And then we're going to move on with transport, supply, resiliency. We are bringing back one of the stage favorites from yesterday, so you don't want to miss this panel discussion. If you're joining on the web stream, 10 minutes. I'll see you then.
Plus.
We founded Plus to create a future where autonomous trucks make freight transportation safer, more efficient, and better for the environment. Our strategy is to use the data we gather from our global Plus Drive fleet to develop the safest autonomous driving system that is 100% driverless.